Hi, and today we're going to look at graphing quadratics from table of values. Even though we're in the solving section, it's always good to kind of have a recap. So graphing quadratics from a table of values requires plotting points and approximating the curvature line as best as possible. You're going to see what I mean by approximating because I'm doing this on a little tablet, it's not that most accurate for me as I would normally like. It's actually more accurate probably on paper. You can kind of do sketch lines. Here we have graph y equals x squared minus 2x plus 1. We've already solved this out and found out that we had this table of values. So this section is only on plotting from the table of values. So we have minus 2 on our x, and then we're going up to 9, and we'll make our little point. Looking at our next, if you want, you can cross them as you go. Negative 1 and 4. So negative 1 up to 4. Second point. 0 and 1. 1 and 0. And lastly, 2 and 1. So, at this point, that's why I said you want to kind of approximate. So, do as best you can. Right, extending as far as you can. And keep in mind, it doesn't meet at a V down there. It meets at a U. So, try and just guesstimate as best as you can, right, where these points could be. Because it is symmetrical, so one thing you can actually do, and that's what I did, is I know that that was going to be a point there, and that was going to be a point there. Because if it just keeps going, these points will repeat on either side, right? So, just stands to reason they had to be there. Don't worry if you don't really see that right away. Just try your best. We're going to use these lines going forward, so these same graphs in videos to come. So, next one. We have these points, so let's go and plot them once again. So here, negative 2 and negative 1. Then we have negative 1 and negative 2. Then we have 0 and negative 1. Then we have 1 and 2. And 2 and 7 right there. So let's go and start to try and plot them as best we can. Right? So that's why I said if I'm trying to do sketch lines almost with this because I'm actually finding it is helping me too. This is normally what I would do when I'm doing paper. And that's what I said. So we have this value here at 1 and 2. Well, we know that our next value over here should trace over the same. So we can kind of make a point there. So this is using, if we extended our table of values, we'd get this. So same thing, we can go across from this point, and we know it's going to be one more over. So therefore, we can get a better approximation of where our curvature will go if we continue on and fill up our graph, which is usually the point, right? Because in this way we can extrapolate and interpolate, not just interpolate values. So our last one we're going to go through is this one right here. So once again, negative 2 and 9. So we're going to look over here, negative 2 and 9. Negative 1 and 5. Negative 1 and 5. 0 and 3. 1 and 3. And 2 and 5. Remember, this is that one I pointed out in the last video. I kind of mentioned a turning point. But just to kind of show you that we don't really know what it's going to look like. This is why, because we got it down to here. And similarly, we knew it went up here, and we could approximate that next point here, so I could continue it up there. We've dealt with that. But what happens when we don't really have a minimum right there? Right? We can't identify one? Well, you can use a little bit of knowledge that, well, it looks like it should be halfway in between there from what we know about taking averages of, say, a median, right? We can think of it like that, or a midpoint, right? There's lots of kind of middles that we could think about. I would like to refer to it in this case as maybe you're just trying to find your median, right? Because what does that happen? Well, that happens at 0.5. So 0.5 in our x, right? Well, how is that really going to help us? Well, the reason that helps us is that we could plug in this 0.5 into our function. So we could do f at 0.5, and that will give us our y value at our line of symmetry. So here we plug it in 0.5, and we're going to square that. Minus 0.5 plus 3, we're going to get 0.25 minus 0.5 plus 3. And so this is going to result us in 2.75. So here, then we can look over here. So we have a 0.5 and 2.75. So right about there. So we can say, hey, we can get a better accurate knowledge of it. So what I just showed you here, we'll end up actually using for this problem later on. So if you kind of missed it out this time, we're going to look at it again when we do turning points.